14.6, apply sum and difference formulas. So we'll be using those 6 formulas that you got in your notes to solve all of these problems. These 6 formulas will be included on your identities cheat sheet. This is for the test, or like for the quiz, I guess. So you'll write them for the quiz, and then the cheat sheet from the both quizzes together will be able to be used on the test. So basically, you're going to prove to me that you can do them on the quiz the same way that you did on this last one, and then you can use that or like have the cheat sheet for the test. So, all right, find the exact value of the expression. So we have the sine of negative 165 degrees. So I need to find, first I need to find a coterminal angle that's positive, okay, so that I can deal with that. It makes it easier to deal with. So how would I find a positive coterminal angle for negative 165? Add what? No. 360. So this is going to be negative 165 plus 360, which is 195 degrees. So I'm going to look at this as the sine of 195. Now, I need to pick 2 values off the unit circle, 2 angles, that when added together, add up to 195 degrees. And there's going to be a lot of options, right? So we could add, you're going to pick a set, and, Maya might pick a set, Tristan might pick a different set, Bella might pick a different set, but they all are going to give you the same answer, okay? As long as the 2 numbers that you pick off the unit circle add up to 195 degrees, your answer in the end is all going to be the same.
You choose a radian?
Well, what is this?
It'll be 5 or 6 plus 5.
Okay, what is this?
195 degrees.
Okay, 195 what?
Degrees.
So what do we think we're using? Degrees. So I need 2 numbers that when added together give me 195. 150 and 45, so this will be the sine of 150 plus 45. Okay, and like I said, there's different values that you could pick instead that would give you the same result. Yep, 135 and 60 would also work. And so, it's up to you which one you end up picking, but we'll just go with this one because this is the first one that was said. So now I take the formula that I had. Okay, so the sine of 2 numbers being added together is the sine of 150 times the cosine of 45 plus, so same sign, the cosine of 150 times the sine of 45. So then, from the unit circle, what is the sine of 150? Sine. 1/2. What's the cosine of 45? Root 2 over 2. Plus, what's the cosine of 150?
1/2. Oh. Root 3 over 2.
Negative.
Negative root 3 over 2.
Negative root 3 over 2. What's the sine of 45?
Root 2 over 2.
Root 2 over 2. So now we would multiply and combine them So the denominator is going to be 4. This one up here would be root 2. Then I have negative root 3 times negative root 3 times positive root 2, which is going to be negative root 6. And that would be your answer. So root 2 minus root 6 over 4. Now, based on the way that you set it up, because we could have said the sign of 45 plus 150, obviously, if we had done that, the order's going to change, but the number's still going to be the same, because this would be equivalent to negative root 6 plus root 2 over 4. Okay, right, so if we'd flipped the numbers, it would have looked like that, but the same answer. So when you're checking your answers, the only reason I'm telling you this is the book is typically going to write it so that the negative sign is between the numbers, but if you add it like this, it's totally fine. They just don't like the negatives out front because it can get confusing. 6, the cosine of 15 degrees. Now, are there two numbers on the unit circle that I can add together to give me 15 degrees? No. But I can subtract. Okay, that's the other thing. That's why there's some indifference formulas. So I can pick two numbers to subtract. So what numbers would you like to pick to give me 15 degrees?
45 and 30.
45 and 30. So this is going to be the cosine of 45 minus 30. So this formula would be cosine 45, cosine 30, plus, so it's opposite signs for cosine, sine of 45, sine of 30. So what is the cosine of 45? Root 2 over 2. Cosine of 30? Root 3 over 2. Plus sine of 45. Root 2 over 2. Sine of 30. 1/2. So then I've got root 6 plus root 2 over 4. Now, what do you notice about both of these answers so far? Yeah, they're pretty similar, right? So for sine and cosine, almost all of your answers are going to look like this in some fashion, okay, based on what's being added and subtracted. They're going to have some form of the numbers, like the square root of 6, square root of 2, 4, and then tangents, you'll deal with like 2's and square roots of 3. So, like, those are, like, the primary numbers. So if you get something other than that, you've probably done something wrong in most cases. All right, 8. This one is the tangent of 17 pi over 12. Now, not a value on the unit circle. And what kind of number is this? Like, yes, it's a radian, but, like, what kind of number is this? Like, it's not a whole number, it's a... Okay, yes, it's a fraction, right? So, I want to pick two numbers to add together that give me 17 pi over 12. But they have to be known values from the unit circle. So that means that I would have to find two numbers that I think add up to that, get a common denominator to add them together, right? Which seems like a lot of work. So what I'm going to do, and what I'm going to tell you to do, is to convert from radians to degrees and then use the degree value to find this, because it'll make your life so much easier. Okay? I tried the first year that I taught this to make them keep it in radians, and they were like all over the planet with their answers, because trying to add together two fractions that then you have to check and see if it has a common denominator. I mean, it was taking like 10 minutes to do a problem that should take like 2. So we're going to convert from radians to degrees. So every single problem that you do in this section is going to be done in degrees. Okay. to make it easier. So that means I got to throw back to conversions. How would I convert 17 pi over 12 to degrees?
17 pi over pi
And then 100 times 100. 180 out of it.
Yep, times 180 over pi. So pi's cancel. And that ends up giving us 255. So now 255 is not directly on the unit circle, so I need to get two angles that add or subtract. Okay, you can choose whichever one you want to give me 255.
210 and 45.
210 and 45. So, tangent formula, we have the tangent of 210, same sign on top, plus the tangent of 45 over 1 minus, so opposite sign on the bottom, tangent of 210, tangent of 45. Now, if you type this in, or well, you're not typing it in, but like, let's hypothetically say this was a different problem and you were typing this in, you would need to make sure that you're paying attention to that. And you still need to, even though we're not typing it in, make sure you do this multiplication first and then do 1 minus that at the end. So, what is the tangent of 210?
Root 3 over 3.
Root 3 over 3. And tangent of 45?
1.
Over on the bottom, 1 minus root 3 over 3 times 1. Now, what's the problem here? Or, like, what would I need to do to be able to solve this?
cubed. Because of the radio in the bottom?
Can you cross out the root?
No, because it's being added or subtracted.
Root 3 over 3 over 1.
No, can't do that. If I want to add a whole number and a fraction, what do I have to do to be able to do that? Get a what? Common denominator. So I'm going to change this 1 to be root 3, or to, sorry, not root 3, to be 3 over 3. And same thing down here on the bottom. So now on top I have 3 plus root 3 over 3 all over on the bottom. 3 minus root 3 over 3. Now what can I do? Cube change flip. So it's going to be 3 plus root 3 over 3 times 3 over 3 minus root 3. 3's cancel. So I'm left with 3 plus root 3 over 3 minus root 3. Now, do we think we're allowed to leave it like that? What might I need to do then?
Multiply the top and bottom by 3 minus 3.
Almost. Your sign is wrong. So we need to use the conjugate of the bottom because we're trying to get rid of it on the bottom. So we're going to be multiplying by 3 plus root 3, top and bottom. So I have 9 plus 2 root 3 plus 3. Wait, 6 root 3. Because 3 root 3 plus 3 root 3, 6 root 3. Okay. Over on the bottom, this is the difference of squares, so it's 9 minus 3. So I've got 12 plus 6 root 3 over 6. Now what?
Simplify.
How?
Take 6 out.
of what?
And then 12. And so it's 2 plus square root of 3.
Yes. Okay. So I'm going to write out this step just as a reminder, but I have to take the 6 out of both pieces to be allowed to cancel. Okay. So then that goes away, and I'm left with 2 plus square root of 3. Now, you're probably like, that was awful. Yes, the tangent problems are much longer than the sine and cosine ones, but some of those steps you could kind of skip writing, right? I'm writing out every single step because I want to make sure we're seeing what's happening. But if you can, if you can go straight from here to here, that's fine. I'm showing it to make sure you remember that the 6 has to come out of both pieces, because that's the most common problem with these, is people forgetting that it has to come out of both. But all your tangent answers should look very similar to these, other than, like I said, the sign of it might be different on something, but that's tangent's all going to look like that. Sine and cosine are all going to look like these up here in some form or fashion, just because of the numbers that we're using to do them. Let's see. The next one, say to evaluate the expression given that, so this is going to have, for the next several problems, this is going to be the information. Cosine of A is equal to 4 over 5 with 0 less than A less than pi over 2. And then sine of B is negative 15 over 17 with 3 pi over 2 less than B less than 2 pi. So before I even start these problems, I need to draw the triangles, okay, much like you see written on my board over on that side. See what I'm talking about? Okay, much like that, that's what we need to do. We need to set these up, okay? So what quadrant is triangle A in? Where's 0 to pi over 2? 1. And what about this one? What's B?
4.
Quadrant 4. So before I do absolutely anything with these problems, before I even tell you what the problem is, we need to set up these triangles to be able to solve, okay? So I'm going to do triangle A over here. So triangle A is in quadrant 1. I'm given the cosine value, which is adjacent over hypotenuse. So this is going to be 4. This is 5. And I've told you before, what does that mean this side has to be? It's Pythagorean triple.
Oh. 6. 4.
For a hint, you can look at that mu alpha theta board up there. Count the number of squares on each side.
Oh.
So look, the M has 1, 2, 3, 4 little blocks,
Yeah.
okay, making the side of the triangle. The theta has 1, 2, 3, 4, 5. Okay, how many does the A have?
3.
3. It's a 3, 4, 5 triangle. It is a Pythagorean triple. It's a special triangle.
Right there.
Oh, yeah.
Okay. I see it now.
I was expecting that to make a little more sense a little
Did
faster,
they
but
explain that to you, like, when you first got the flag? Like,
that flag's been here since I was in high school. It was like last year sometime I realized that it was the Pythagorean triple, like that it made. But I mean, I've known that Pythagorean triple since high school. But yes, that is one of the Pythagorean triples.
The more you know.
Yeah. So, now I have that triangle. Let me do the other triangle now. I'll do triangle B. So this is A, this is B. So this one is down here. So sine is opposite, so negative 15 over 17. And I need to get the other side. So I would do square root of 17 squared minus 15 squared. I don't know that off the top of my head. Square root of 64, which is 8. So now what I'm going to do, okay, I don't need cosecant, secant, and cotangent for these problems, right? This is all the same section of sum and difference formulas. So all I need to do is I want to write out sine of A, cosine of A, which I'm given, and then tangent of A, and then I'm going to do the same thing for triangle B, okay? Because I'm going to use that to solve the following problems. And since we'll have it set up, you can just use that to do your homework problems. Just know on the test and quiz, I'm not going to set it up for you. You're going to have to set it up yourself. So what is the sine of A? It's the sine of this angle right here. 3 over 5. Cosine of A was given to us as 4 over 5, and tangent of A would be what? No. Tangent. 3 over 4. Then over here, sine of B was given to us, negative 15 over 17. Cosine of B would be cosine.
Oh, 17.
Tangent of B. Yes. All right, so now I've done all the hard work. So now the next part is easy. We're actually solving the problem. So 12, we have the sine of A plus B. So how would I write out this formula in terms of A and B? We'll replace it with numbers in the next step. Like, what would the formula be?
Sine A.
Cosine B plus cosine A sine B.
Yes. So then sine of A is 3 over 5. Cosine of B is 8 over 17. Plus cosine of A is 4 over 5. Sine of B is negative 15 over 17. Now, the difference in these problems, obviously, from the last ones, okay, is these answers aren't going to be square root of 6 plus square root of 2 over 4, right? These answers are obviously going to be different. Those were that way because they came off the unit circle. The nice thing about these is most of the time you should end up with a common denominator, if not all the time, just because of the nature of how they set up. So we've got 24 plus, or I guess it's minus, 60 over 85. So that would be negative 36 over 85. So once you set up your triangles, it's not too bad. Um, 14, tangent of A plus B. What's the formula for this one?
Tangent A plus tangent B over 1 minus parentheses tangent A plus tangent B. No plus, just
Yeah. And I'm going to tell you, like, these tangent ones are not going to be as bad as the other ones because the other ones are pretty much always going to end up with square roots in them, which means you have to, like, deal with all the rationalizing stuff. But these ones don't have that, so it'll be a little better. So tangent of A, can't go too far away, 3 over 4 plus tangent of b is negative 15 over 8 over 1 minus tangent of a is 3 over 4. Tangent of b is negative 15 over 8. So I would just rewrite sub as a common denominator all in the same step if I can. So I'm going to rewrite this as 6 over 8. So I've got negative 9 over 8 over, I know this is going to have a denominator of 32, okay, because 4 times 8 is 32. So I'm going to write this as 32 over 32 minus, nope, plus because of the sign, negative and negative, so positive. So 45 over 32, which is going to be negative 9 over 8 over 77 over 32. Keep, change, flip. Negative 9 over 8 times 32 over 77. 8 and 32 become 4. So that ends up being negative 36 over 77. So still obviously have to do the keep, change, flip and deal with fractions and fractions, but we don't have to do the rationalizing, so it goes a little faster. And again, if you can do some of that in, you know, one step or something, that's fine. As long as you're confident in it. Um, 16, cosine of A minus B. What's the formula for this one?
Oh, cosine A plus cosine B plus A plus
What signs go in between it?
plus or minus.
Which one?
Plus.
Plus. Opposite for cosine, same for sine. So cosine of A was 4 over 5. Cosine of B is 8 over 17. Plus sine of A was 3 over 5. Sine of B, negative 15 over 17. So on the bottom, that's 85, because we'd already found that number. Then I've got 32 minus 45, so that's negative 13 over 85. All right, these next couple, I'm going to see if you can guess what I'm going to have to do to solve these. So 20, simplify the expression. Sine of x plus pi.
You're gonna have to change the pi to this.
You can, but you don't need to. Good guess, though. What does this look like?
Whatever you do last chapter. Or,
How about what we're doing right now?
okay.
Does this not look like this?
Oh, yeah.
Okay, so I want to rewrite this in terms of the formulas that I have. So this would be sine of x, cosine of pi, plus cosine of x, sine of pi. So the difference is we have an x now, which obviously we don't know what that value is, but I can do the ones that I do know the value for. So what is the cosine of pi?
-1.
So this is going to be sine of x times -1, which if you wanted to just write it as negative sine of x, you can. Plus, what's the sine of pi?
0.
Yep. Sine of pi is 0. So this piece goes away over here, and this would be equal to negative sine of x. And that would be your answer simplified. (22) Tangent of x minus 2 pi. So we've got tangent of x minus tangent of 2 pi over 1 minus tangent of x, or wait, plus. Opposite sign on the bottom, right?
I wish you messed up and just, that's not
Yeah, opposite sign on the bottom. 1 plus tangent x times the tangent of 2 pi. What is the tangent of 2 pi?
Zero.
So tangent of x, this would be 0, so that's gone. This piece here is 0, so I would just have on the bottom 1 plus, well, tangent of x times 0, which is just 1, right? Or, sorry, 1 plus tangent of x times 0 would just be 1 on the bottom. So this would just be equal to tangent of x. So these ones for tangent are even better. Even less work. Alright, one more. 30. Cosine of x plus 5 pi over 2. So how would I set this one up?
Cosine a x plus cosine,
Not plus, but
or just
yeah.
cosine 5 pi over 2 minus sine would be a or x.
X, because that's what I'm given.
And then sine 5 pi over 2.
Alright, now cosine of 5 pi over 2 isn't explicitly written on our unit circle, but what is it equivalent to? What is it coterminal with?
He's bottom of it.
One full time around the circle is what?
2 pi.
2 pi. Well, I need to go another pi over 2 past that. So what's it equivalent to? Pi over 2. Alright, so what is the cosine of pi over 2?
0.
0. So this piece is 0. So this whole thing on this side is going to be 0 minus, what's the sine of 5 pi over 2? 1. So this is just going to be equal to minus the sine of x. Alright, any questions about this stuff?
No. Quite nice.
Alright, problems then. 3, 5. Oh, wait. 3, 7, yes.
I'll grab your book, man.
9.
I feel like this is a trap.
And just remember, if there are a negative angle that's given to you, you need to get the positive one. So find the positive angle first. (13, 15, 19, 23, and 25. Now, we're only have like 10 minutes left, so I'm not expecting you to finish these today. So I'll give you some time tomorrow to do this and to work on... Is there a video for 14.7?
Yes.
Okay. So then to do your notes tomorrow in class so that you can get all that done. So if you want to start it now, you can. If you want to wait till tomorrow, that's fine too.